Let me explain something to you that has probably been sitting right in your pocket, completely taking you for granted. Let us talk about the absolute magic trick that is modern smartphone photography, and, more specifically, why the Google Pixel consistently manages to make jaw-dropping photography look completely effortless. If you spend any time watching tech reviews, you've undoubtedly seen the charts, the camera shootouts, and the endless blind camera tests where everyday people overwhelmingly point to the Pixel photos and say, that is the best picture. And every single year, we find ourselves asking the exact same question. How on earth is a phone that often costs less than its ultra-premium competitors somehow delivering a cleaner, more vibrant, and more visually stunning image? Is Google sourcing magical alien glass? Are they hiding a massive DSLR sensor underneath that sleek camera visor? The short answer is no. Physically speaking, the camera components inside a Pixel are remarkably similar to what you will find across the entire flagship industry. In fact, if we look strictly at the laws of optical physics, smartphone cameras hit a massive, seemingly unbreakable brick wall nearly a decade ago. But what makes Google so profoundly brilliant isn't that they found a way to break the laws of physics. It is that they built a pocket-sized digital supercomputer capable of completely outsmarting them. Today, we are going to celebrate the sheer, unadulterated engineering genius that happens behind the glass of a Pixel camera. It is a masterpiece of software choreography that executes trillions of calculations in the blink of an eye, just to make sure your morning coffee looks like a work of art. To truly appreciate what Google has achieved, we first have to understand the nightmare scenario that smartphone engineers face every single day. If you want a traditional camera to take a breathtaking, clean photo in low light, the recipe is incredibly simple. You use a massive physical sensor and a large, heavy piece of glass to gather as many physical photons as humanly possible. But consumers have made it abundantly clear that they do not want to walk around carrying a literal brick in their pockets. They want phones that are slim, pocketable, and elegant. This creates a hard limitation on the thickness of the device. Because the phone cannot be thick, the glass elements cannot sit far away from the sensor, meaning the physical size of the camera sensor is permanently frozen. When the entire industry ran face-first into this physical limitation, most companies kept trying to force minor, incremental hardware upgrades. But Google took a step back, looked at the brick wall, and decided to entirely rewrite the rules of the game. They realized they were a world-class software and data company competing in a hardware race. So, they changed the race. They looked at the tiny, physically limited camera sensor and said, "We do not need a bigger net to catch more light, we just need to become infinitely smarter at processing the light we do catch." This was the genesis of computational photography, and it completely revolutionized how humanity captures memories. The absolute cornerstone of this genius approach is a proprietary software pipeline that Google pioneered called HDR+. To understand how mind-blowing this is, let us dismantle the illusion of what happens when you actually open the camera app on your Pixel. You see, when you tap that camera icon and look at your screen, you naturally assume the camera is just resting, casually waiting for you to tell it what to do. That is completely wrong. The moment the camera app opens, the Pixel goes into a state of hyperactivation. The physical sensor instantly begins firing at maximum capacity, continuously capturing a rapid-fire, rolling loop of 10 to 15 full-resolution raw images every second. It dumps this massive fire hose of data into a temporary, ultra-high-speed volatile memory buffer, constantly recording and overwriting a continuous window of the past. When you finally press the physical shutter button on your screen, you are not actually telling the camera to take a picture. Your finger is simply giving the processor a command to freeze time. You are telling the system to grab the bundle of frames it already captured a fraction of a second before you even decided to press the button. This is why Pixels have virtually zero shutter lag. The photo already exists in the temporary buffer memory. But grabbing the frames is only step one of the symphony. The real magic happens inside the image signal processor and the dedicated neural chips. The Pixel takes those raw frames, which are intentionally slightly underexposed, to ensure the bright highlights like the clouds in the sky or a bright street lamp are not blown out and ruined, and begins an aggressive mathematical alignment process. It looks at all the frames simultaneously, mapping them pixel by pixel. If your hand shook slightly, or if a car drove through the background, the software detects the movement and micro-adjusts the layers to line up flawlessly. By stacking up to 15 individual photos on top of one another, Google's math does something physically impossible for a single exposure. It completely cancels out digital noise. In dark areas of a photo, a tiny smartphone sensor naturally produces ugly, multicolored grain because it is struggling to read the lack of light. But by looking at 15 different copies of the exact same shadow, the algorithm can easily separate the random digital noise from the actual, physical details of the scene. It mathematically scrubs the noise away, brightens the deep shadows, preserves the brilliant highlights, and paints a final, pristine composite image. All of this heavy lifting, which would normally cause a heavy desktop workstation to break a sweat, happens in a fraction of a second before the file is even saved to your permanent camera roll storage. It is an astonishing display of software optimization. Now, you might be wondering, if this is all just software and math, why cannot every other smartphone manufacturer on the planet just copy Google's homework and replicate the magic? After all, many flagship phones run on the Android ecosystem. This is where Google pulled off their ultimate competitive masterstroke. They took their legendary HDR Plus formulas and locked them away in a highly guarded, proprietary vault. The foundational code of Android is open to everyone, but the specific, deeply sophisticated mathematical models that govern how a pixel perceives color, manages contrast, and maps human skin tones belong exclusively to Google. To take it a step further, Google realized that off-the-shelf mobile processors bought from third-party manufacturers were starting to limit their software ambitions. The generic processors were fast, but they were not custom-tailored to run complex machine learning algorithms at the blistering speeds Google required. So, Google made one of the most financially audacious moves a tech company can make. They started designing their own custom silicon, the Tensor chip. The architecture of a Tensor chip isn't built to win superficial speed tests on a benchmark chart. Instead, Google dedicated a massive amount of the chip's physical real estate to a specialized engine called the Tensor Processing Unit, or TPU. This unit is hardwired for one primary purpose: to execute machine learning and deep learning models locally on the device at terrifyingly high velocities. When you take a photo in a dimly lit restaurant, the pixel is not just running a basic color filter. It is running an advanced machine learning model that has been trained on millions of professional, mathematically perfect photographic examples. The chip instantly analyzes the scene, recognizes that it is looking at a human face, understands what natural skin tones should look like under warm lighting, and dynamically calculates the perfect exposure. It is a level of vertical integration where the custom silicon, the operating system, and the proprietary AI are all shaking hands in perfect unison. But Google did not stop at redefining still photography. They eventually turned their sights toward the ultimate computational nightmare: video. If processing 15 frames for a single photo requires a massive burst of electrical and mathematical power, imagine trying to apply that exact same heavy AI noise reduction, complex color grading, and dynamic range mapping to a 4K video running at 60 frames every single second. A smartphone chip trying to execute that level of rendering locally would literally turn the device into a pocket-sized space heater within 30 seconds before thermal throttling kicked in to save the hardware from melting. So, how did Google solve this seemingly absolute bottleneck of mobile processing? They looked beyond the physical device entirely and introduced a feature called Video Boost. When you toggle this feature on and shoot a complex high-contrast or low-light video, the pixel records a high-quality temporary file directly from the sensor. But the moment your phone connects to Wi-Fi, it quietly uploads that massive raw video file directly to Google's industrial-grade cloud infrastructure. Suddenly, the processing burden is stripped away from the tiny, passively cooled smartphone chip and handed over to massive, liquid-cooled, warehouse-sized server farms packed with enterprise-level Tensor hardware. These industrial supercomputers run Google's most advanced, heavy-duty AI processing models frame by frame over your entire video clip. They scrub the low-light noise with extreme precision, optimize the stabilization, elevate the dynamic range, and essentially execute a Hollywood-grade automated post-production pass on your footage. A few hours later, the cloud infrastructure quietly downloads the perfected, cinematic masterpiece back to your device, seamlessly replacing the noisy original. The next morning, you press play. Your jaw drops at the stunning clarity of the video, and you marvel at what your phone just captured. In reality, your phone did not render that masterpiece. A sprawling network of supercomputers halfway across the world did it for you. It is an absolute masterclass in using infrastructure to bypass the physical constraints of handheld consumer electronics. And let us not forget how Google completely altered our relationship with time itself through features like Best Take. We have all been there. You try to take a group photo of your family or friends, and it is a psychological battlefield. In the first shot, Uncle Bob is blinking. In the second shot, your sister looks away. In the third shot, someone else has a bizarre expression. Historically, that memory was just compromised. But the pixel looks at that burst of photos and completely deconstructs the timeline. The internal AI mathematically identifies every individual face in the frame, maps their unique geometry, and presents you with a menu of the different expressions captured across the entire session. You can literally select Uncle Bob's face from the third photo, where his eyes were open, and the software will seamlessly slice, track, blend, and paste it onto his body in the first photo. The final image saved to your gallery is technically a completely synthetic composite. It is a beautiful, flawless moment that never actually existed simultaneously in real life, but represents the exact perfect memory you wanted to keep. When you add all of these pieces together, the zero shutter lag buffer, the custom Tensor silicon, the proprietary machine learning skin tone models, the cloud-based video rendering, and the temporal face stitching, you realize that Google didn't just build a better camera app. They built a revolutionary visual engine that respects the consumer's desire for convenience, while refusing to let the physical limitations of hardware dictate the quality of their memories. They pour billions of dollars into research, development, and infrastructure solely to ensure that when you pull your phone out to capture a fleeting, beautiful moment, the technology completely vanishes into the background, leaving you with nothing but a breathtaking image. It is an extraordinary engineering achievement that genuinely deserves our utmost appreciation and respect. So, the next time you tap that shutter button on a Pixel phone and watch a perfectly balanced, vibrant, noise-free image instantly appear on your screen, take a brief moment to appreciate the invisible, silent marathon that just occurred underneath the glass. Trillions of calculations, custom-designed neural architecture, and decades of advanced software engineering all sprinted across the finish line in a millisecond, just for you. That is the sheer genius of computational photography. And that is exactly how Google continues to completely rewrite the future of how we see the world. Thank you so much for hanging out and diving deep into the fascinating world of tech engineering with me today. If you enjoyed pulling back the curtain on how these devices actually think, make sure to smash that like button, subscribe to the channel, and drop a comment below, letting me know what mind-blowing piece of technology you want me to deconstruct next. Until next time, I am Sal, signing off. Take care, stay curious, and I will catch you in the next one.